Hello students, in this session we'll be studying about process activities. In the previous class we have seen there are a lot of models which we'll be making use for development of any application, right? And there we have seen there are particular stages like specification, then we have design, implementation, testing, evolution, all these things. And we have studied that they are going like separately, but actually in real business what happens is when we are building an application in a real world, real software processes are interleaved sequence of technical, collaborative and managerial activities with the overall goal of specifying, designing, implementing and testing a software system. That means they are not different. That means will not have particular stages over there. They are interleaved. That is, there will be a mixing of all these things, but our goal will be of development of any software. The four basic process activities are nothing but specification, development, validation, evaluation. These are all the things that will be going through the development of any process. In the waterfall model, they are organized in sequence, whereas in incremental development, they are interleaved. In the previous class, we have seen regarding the various models as I already explained, like waterfall model. In waterfall model, what is the important thing is we'll be having a particular sequence, right? We have to follow a particular sequence, then only we will be able to develop any application. But if you proceed with incremental development, wherein all the activities are interleaved. Now we will see the first and foremost uh, part of any development of any software is software specification. The process of establishing what services are required and the constraints on the system's operation and development is nothing but a specification phase. Right. In this phase, there will be formal, informal interviews with the various clients, and here we are going to understand what are the requirements of the various customers. Right. What are the things that are required by the various clients. Based on this, we'll be proceeding for development of any software. So this is one of the important stage, right? If you understand this stage very clearly, then only we can proceed with the remaining things, because everything is dependent on this particular stage. Now we will see what are the things that we'll be having in this requirements engineering phase, right? Requirements engineering process has feasibility study, then we have requirements elicitation and analysis, requirement specification, then requirements validation. So these are the important things that will be going through during the requirements engineering phase. First one is about the feasibility study. In feasibility study, what we are checking is it technically and financially feasible to build the system? Here we are checking whether whatever the requirements that have been given by the client, whether in a particular budget we can be able to produce the produce the software or not, or whether technically we can develop the application that is required by the customers or not. So everything is being defined over here. So here what we'll be having is an estimate is made of whether the identified user needs may be satisfied using current software and hardware technology. That is, whatever the hardware and software that we have, whether we can make use of that and build an new application or not. That is, we are going to study. Apart from that, the study considers whether the proposed system will be cost effective from a business point of view, because if it is a fixed budget project, then within that budget we have to develop an application and we have to give it to the customer. If it is overrunning the budget and all, then will whatever the company that is producing a particular application, it will be in a loss. So that should not happen. So that is the study that is going on. And apart from that, a feasibility study should be relatively cheap and quick. That is, whatever the study we are doing, feasibility study, that should be very relatively cheap, and within a particular time frame we have to come to a conclusion whether we can proceed with the things or not, right? The result should inform the decision of whether or not to go ahead with a more detailed analysis. So this is the first thing. Then we have requirements elicitation and analysis. Here what we are checking is what do the system stakeholders require or expect from the system, right? in detail we'll be going through this. So this is a process of deriving the system requirements through observation of existing system, right? If you are building a new system, we have to go through a existing system, what are the faults over there, what are the drawbacks of that, and we have to discuss with the potential users and the procurers. Task analysis has to be done, and there are a lot of things that will be going on in this requirements elicitation and analysis phase. This may involve the development of one or more system models and prototypes. Here we'll be not going with only one prototype and proceeding with the things. We'll be looking for what are the different alternatives for the particular solution, right? Then we'll be picking up the most profitable prototype, and we'll be developing an application. This help you understand the system to be specified. Once this is done, then we'll be going for the requirement specification phase, that is defining the requirements in detail. Here what we do is requirement specification is the activity of translating the information gathered during the analysis activity into a document that defines a set of requirements, right? Whatever the requirements we have gathered till now, it should be properly understood, and we have to make a proper document over here. Two types of requirements may be included in this document. We are going to classify them as two things. One is user requirements, and another one is system requirement. User requirements are abstract statements of the system requirements for the customer and end user, right? For customer and end user, we'll be developing a document that is a user requirement document, and for the developers of a system, we'll be having a system requirements. Okay, we're going with system requirements, which is more detailed, which is having more description regarding what the system has to do, and whatever the functionality we have to take into consideration, we'll be having an depth knowledge regarding that, right? So that is a system requirement. Once this is done, then we'll be having a requirements validation. So requirement validation, what we are doing over here, checking the validity of the requirement. That is, this activity checks the requirements for realism, consistency, and completeness. That is, here we are checking whether all the requirements given by the various stakeholders has been incorporated in this document or not, and whether we can really proceed with the software. All these things we have to discuss in this over here. During this process, errors in the requirements document are inevitably discovered, right? Once we are in a validation phase, here we have to check whether whatever the requirements we have collected, everything is fine, or is there any difficulty in understanding the requirements, and if it leads to, I mean, if it is not understood properly, then it might lead to a different software which is not purchased by the clients, right? So this should not happen. It must then be modified to correct these problems. If any problems are discovered in the requirement document, then we have to correct it, and we have to proceed further. This is the requirements engineering process, which is one of the important part, right? Here what we have is feasibility study. First thing is a feasibility study, wherein we are going to check whether technically whether we can proceed further or not, and whatever the amount that is sanctioned for the particular project, within that particular budget, whether we can develop an application or not. Everything is being considered over here. So that is a feasibility study, and output of the feasibility study is a feasibility report, right? Once the study is done, we'll be having a report with us, right? We will be developing a report, and in this report it will be mentioned whether we have to proceed with the project or whether we have to stop it here itself. That is, we will not take this project over here. Then what we have is, after the feasibility study is done, then we go for requirement elicitation and analysis. In requirement elicitation and analysis, we'll be having thorough knowledge, right? That is, here we are going to discuss much more like whether we have to consider the requirements or not. Whatever is being given by the customer, everything should not be accepted, because there will be some requirements which cannot be taken into consideration, right? So all this thing is going to happen, right? Once this is done, the output of this is nothing but a system models. After this, we have requirement specification phase. That is, after the elicitation and analysis is done of the various requirements collected, we'll be having a documentation, right? That is nothing but a requirement specification phase. Once that is done, we'll go for requirements validation, wherein we are going to validate the requirements by showing it to the customer, right? These are the set of things that we have noted, and whether uh, we have to proceed further or not, right? So that is the thing, right? After the requirement specification, we are going to separate the user and the system requirements, and once the requirement validation is done, at last we'll be having requirements document. Now we will study about software design and implementation part, right? That is the second thing. After the requirement is collected, the second thing is designing and implementing. The process of converting the system specification into an executable system. Here what we have is two parts, right? System software design, and another part is implementation part. In the first part, we are going to design a software structure that realizes the specification. We have specification document with us, and after we have this document, we have to build the things, right? We have to have a overall architecture of the system that we are going to build, that will be taken care during the software design part. After that, we will have a implementation. Once a design of the software is with us, once our overall architecture is with us, next part is our implementation part, wherein we are going to translate this structure, whatever the structure we have got after the software design phase, that structure is now converted into an executable program, right? The activities of design and implementation are closely related and may be interleaved. That is, they go hand in hand, right? Whatever the design phase and implementation phase we have, because whatever the design is done, that's the implementation starts, right? So they are interleaved. This is a general model of the design process, right? Whatever might be the design that we are going to have, it will be having what design inputs, design activities, and design outputs. If you want to go through this design phase, then we require the inputs like platform information, on what platform the particular application will be running after it is deployed, right? Then requirement specification, what are the things that should be incorporated in the application that we are going to develop, and apart from that, what kind of data is going to be fed up for this application. Everything is a input for us. Once we have this, then we'll be going for the design activities. That is, if I want to develop an application, we should have a architectural design, right? We have to have an interface design. Then output of this interface design is taken as a reference for developing and component design, right? Then we have database design. So these are all the activities that we'll be having in the design phase. Now we'll see what are the outputs that we are going to have from this design phase. Once the design phase is done, right, once it is completed, we'll be having software architecture with us, then database specification will be with us, then interface specification and component specification. These are the byproducts of the design phase. Right, the things like the various design activities are explained in this slide, right? First we have architectural design, wherein where you identify the overall structure of the system, right? Whatever the overall structure of the system we are going to have, that will be explained in this. The principal components, what are the different components that we'll be having in the application that we are going to build, that will be present over here, and their relationships and how they are distributed. Every information is shown in this architectural design. Then we have interface design, where you define the interfaces between system components, right? We'll be having multiple components in our software. Now the thing is, there should be some linking in between the various components from where the information is going to pass, right? So that is the interfaces are required. Interface design will be done. Then we have component design, where you take each system component and design how it will operate, right? Once that is done, we'll go for database design, where you design the system data structures and how these are to be represented in a database. So all these design activities are going to be happening in the design and implementation part. Then we have software validation. Software validation is a part wherein verification validation is intended to show that a system conforms to its specification and meets the requirements of the system customer, right? Whatever the requirements have been given by the customer, whether we have understood and properly written or not, everything is being validated in this in software validation process. It involves checking and review process and system testing. Right, here we'll be having a thorough checking of the system, whatever we are going to develop, then reviewing the process that we will be applying for developing an application, and system testing. Our testing as a whole will be carried out. That is, system testing involves executing the system with test cases that are derived from the specification of real data to be processed by the system. Once this is done, testing is the most commonly used verification and validation activity. We call it as V&V activity, that is verification and validation. Now we will see regarding the various stages of testing. We have component testing, system testing, and acceptance testing. Component testing is nothing but if I want to build a application, a bigger application, we are going to consider various components in that. Single component is tested separately, right? Once a single component is tested properly, and if there are no bugs present over there, then what we do is we will go on adding the various components, right? Because we require a system as a whole. Then what we do is a particular component is taken and it is joined with the second component, right? And after that we are going with merging of various components, right? So then we'll have a system, right? Then what we have to do is, as a system as a whole, whether everything is working fine, right? That is system testing. And once the system testing is done, then we'll go for acceptance testing. That is, we have tested there are no problems in the application that you have built. Now you have to give it to the user, right? Before user is going to purchase, he is going to check whether there are some bugs present or not, right? Now what we have to do is we have to demonstrate and show to the user that there are no bugs present. Whatever the customer has requested, same thing has been developed by the developers. So that is the acceptance testing. Okay, the same thing is explained over here. Development or component testing. Individual components are tested independently. Components may be functions or objects or coherent groups of entities. Then we have system testing, wherein testing of the system as a whole. Testing of emergent properties is particularly important over here, right? When we join multiple components, then there are a lot of things to be taken care, whether timing problem is there or not, and whatever the information we are passing, whether it is passing perfectly, right? Apart from that, we have to look for multiple properties of the various system over there, right? Then we have acceptance testing, testing with customer data, right? Here we are feeding our application with customer data and we are demonstrating the user that everything is working fine. So this is known as a V model of development, right? If we take the inverted image of this, we can see that it resembles V, right? What are the things we are going to consider over here is we require a requirement specification, right? Once specification is done, then we go for system specification. More detail information is gathered regarding what kind of application has to be developed. Once that is done, we go for system design, right? By looking at this, as I already said, by looking at the specification document only, we are going to build each and everything. First we will go with system design, right, wherein we'll have just a glance at the various design procedures. After that we'll go in depth regarding how each and individual things has to be carried out, right? Here we'll be having a module and unit code. Then we go for testing of each and every component. In the second layer, we can see there are various test plans, right? Acceptance test plan. How actually we are going to produce this is by taking the requirement specification document and system specification document, we'll be having acceptance test plan, right? The byproduct of system specification and system design is nothing but a system integration test plan. That is, when we are going with integration test, there should be some plan how it should be tested, each and everything over there, right? And you can see system integration test plan, it is a byproduct of system design and detailed design. Once we have collected this test plan, according to that test plan we have to test the things, right? Once you are done with the components, then we have joined the various components. Here we are going with subsystem integration test, right? How we'll be testing this? The test will be conducted according to the subsystem integration test plan. Whatever the plan we had earlier, according to that plan only we are going to test the things. Once subsystem integration test is done, we'll go for system integration test. That is, all components are joined. Now we will be checking whether system as a whole is working fine, right? Then we'll go with acceptance test, wherein user will be giving his own data set and we are checking whether it is working fine, right? Then once everything is done, we'll give that product as a service to the customer. Then we have system software evolution. Evolution is a longest phase of development of any software, right? Software is inherently flexible and can change at any instant of time, right? Why we are changing the system is either if there are any bugs present in the system or the customer is coming up with new requirements, then we have to change our application, right? As requirements change through changing business circumstances, right? If you are using any application in business, then what has to be done over here is, if the way in which the business whatever is being carried out, it changes, then we have to change our application, right? The software that supports the business must also evolve and must change. Although there have been a demarcation between development and evolution, this is increasingly irrelevant as fewer and fewer systems are completely new, right? Whatever the new systems which we are developing, it is actually a not new system, right? What we do is we will be refining the older systems and we will come up with newer ideas. This is a system evolution process wherein we have like we'll be having a existing system, right? Whenever someone come up with new requirement, what he's doing is he'll be finding out the drawbacks in the current system, right? So define system requirements, what should be added to the existing system, right? So once you have these two things, then you will assess existing system, right? You'll be looking for the existing system, then you propose system changes. What are the things that should be changed in the existing system, right? Once you are done with this, then you go for actually modifying the things, right? Once a proposing of system changes is done, then you go for modifying the system, and you go on modifying the system until unless whatever the customer has requested is done. Once you are done with that, then you will be giving that new system to the customer. Then customer will again come up with some changes. So now this will be our existing system, right? Whatever the new system we had given to the user, after few days it will become our existing system, wherein user will be coming up with newer requirements. Again the same process repeats. Okay, thank you for listening.